Question number 4. Figure number 2 shows the circuit diagram that a student built up here. In figure number 2, we can see that there are two fixed resistors. Each one has a resistance of 10 ohms. I give the name resistor A and resistor B. They are parallel to each other. There is a filament lamp that has a resistance of 10 ohms. A sign of the battery is given here. 4.1 is an AO2 question. The lamp has a resistance of 10 ohms. Each resistor has a resistance of 10 ohm. What is the total resistance of the circuit? This question is from the concept of series and parallel circuit. Different options are given here. We need to find the total resistance of the circuit. If you look here, the resistor A and B are parallel to each other. As they are parallel in the circuit, the total resistance of the two resistors is less than the resistance of each individual resistance. As these two resistors are parallel to each other, therefore the total resistance of this parallel circuit is less than the resistance of individual resistor A and B. As A and B both are 10 and 10, therefore the resistance of this circuit is definitely less than 10. Whereas this filament bulb, a filament lamp, is in series to this circuit, so both are in series. Therefore, the total resistance is the resistance of this filament lamp plus the resistance of this parallel circuit. So this is 10 plus less than 10, so it is less than 20. So the possible answer is given here, that is less than 20. 4.2 is an AO3 question where the student need to explain why it is less than 20 ohm. This question is from the concept of the series and the parallel circuit. The possible answer is the total resistance of two resistors is less than the resistance of individual resistor, or the resistors are parallel in the circuit. If you see here, the total resistance of this circuit is less than the resistance of each of the resistor because they are in parallel. That is the property of the parallel circuit. A student must remember this property. The resistance of the lamp is added to the total resistance of two resistors. We know that resistance of the lamp is 10, whereas the resistance of two resistors which are parallel is less than 10, less than 10 ohm. Therefore, the total resistance is less than 20. The student replaced one of the resistors with a thermistor. 4.3 is an year 1 question. Draw the circuit symbol for a thermistor in the box given below, and this question is from the circuit symbol. Student must know the symbol for thermistor. It must be a correct symbol to get 1 mark. 4.4 is an year 1 question, and this question is the student increased the temperature of the thermistor. Explain how the current in the thermistor changed. This question is from the topic of the current, resistance, potential difference, and working of different types of resistors. The key information is given here. The student increased the temperature of the thermistor. This is our thermistor. As the temperature of the thermistor will increase, the resistance of the thermistor will decrease and allows more current to flow through it. If the temperature of the thermistor it decreases, then it has high resistance and less current or no current will flow through the thermistor. Let's see the model answer. The note is given here. The student must know the working of thermistor. It depends on the temperature. As the temperature of the thermistor increases, the resistance of the thermistor decreases there. If the resistance of the thermistor will decrease, so it means that it will allow the current to flow through the thermistor. The student can write the answer other way around, that if the temperature of the thermistor decreases, the resistance of thermistor will increase and less current will flow through the thermistor. 4.5 is an AO2 question, is a knowledge based question where the student need to apply their knowledge. Figure number 3 shows an other circuit the student has built up in which a fixed resistor is present, filament lamp is present, a switch is present which is open. Explain how the potential difference across a resistor and the lamp will change when the switch is closed. If the switch is closed, as I elaborated in my figure, it will provide a path for the flow of the current. When it comes at the junction point, it has two paths. One is the current can flow through the resistor, another is it will flow through the switch. When the switch is closed, the current will flow through the switch because it has very less resistance, and the current will stop flowing through the resistor. And if we use the voltmeter here across the resistors, it will going to show very little value, a very small value, a zero value. The reason is the current is flowing through an alternative path, that is switch. But if we're going to connect a voltmeter across the filament lamp, it will show us that the potential is across a filament lamp because the resistance of the filament lamp is very high. Therefore, the battery is applying more energy against to overcome the resistance in the filament lamp as compared to the switch. Let's see the model answer. When the switch is closed, the current will take the short circuit to flow through it, which it take the short way to flow through it. There is zero potential difference across a resistor. This means the current has taken the route with no or less resistance as compared to the resistor, and no current is flowing through the resistor R. So it has taken the short route from here as compared to the resistor R. So it means the battery is working. The potential difference is shown against the filament lamp. The potential difference across the filament lamp will increase. Here, the potential difference is increasing because this filament lamp has the huge resistance here as compared to this switch. As the resistor has no a less resistance, there is no potential difference across it. So if we're going to connect any voltmeter here, it will show you the zero reading, a very small reading. The whole of the battery potential is used to overcome the resistance of the filament lamp.